Okay, I want us to start thinking about a whole different realm. You know, up to this point, a lot of the things we've been thinking about have been manipulating equations, solving equations, examining equations, graphing equations. Well, I now want to sort of loosen up what we've been doing, and instead of looking at equations, to start looking at the graphs and looking at solutions to inequalities. Now, early on in the review and then some other places, we actually have seen how to solve inequalities, but I now want to start to take a look at how you can start to graph inequalities on axes. So just to sort of inspire this, I want us to sort of think about what a graph of an inequality would look like. Let's start off with the following inequality. Suppose I wanted to graph, let's see, pen here. Suppose I wanted to graph, let's say, y is less than or equal to 3. How would I graph that? Well, the very first step that I would make, if it were me, is to first just graph y equals 3, because that's easier, after all. That's easier. So the first thing I would do is just graph y equals 3. So in fact, let me just make a list of the little things I would do here. So step 1 would be to look at an easier problem. Now, y equals 3. Well, you can do it a variety of ways. You could say, well, that's a straight line, has slope 0, and y-intercept 3. Or you can say, well, where are all the places where y equals 3? Well, that's 3 units above the x-axis. Every point here is y equals 3. So in fact, the graph of that is a straight line that looks just like this. Great. That's this graph. But what about this graph? Y is less than or equal to 3. Well, for this graph, what we have to think about is, well, let's see. What are the points that satisfy this? Well, it turns out that notice that this line has cut the world into two pieces. You could think of this as sort of the up piece, and this is sort of the lower piece. And it turns out that when you have an inequality like this, one of these pieces will actually be filled in. So how could you figure out which piece is filled in? You just can pick a point at random and see if it satisfies this or not. And usually what I do, if I can, is just pick the origin. So I ask, is the point x equals 0, y equals 0, does that satisfy this or not? Well, this only has y's in it, so I just plug in the y. Is 0 less than or equal to 3? Well, the answer is yes, 0 is less than or equal to 3. Well, that means that this point is actually going to be in this solution range. But if that point is, that means this whole range is going to be. Because this will cut the world up, the line cuts the world up into two pieces, and this will represent one of the pieces. Since I see that that point is in there, then I see that everything down here must be in there. So in fact, a way for me to actually graph this would be to sort of shade in everything below that line. So in fact, the graph of y less than or equal to 3 is actually this line together with all this shaded region. Because notice that any point in the shaded region and any point on the line satisfies this. Let's just check. How about that point right there? That would be 1, 2, 3, 4, 5, 6, 7. That's negative 7, 2. And notice that negative 7, 2 satisfies this because the y is all we care about, and the y here is 2, which is less than or equal to 3. So in fact, inequalities and graphing inequalities have the shape that they sort of fill up half of the plane or half of space. Let's try another one just for fun. Suppose we want to graph x is greater than minus 1. How would I do that? Well, step 1 would be first just to graph the line without the, so replace the inequality just by an equality. And then we know what that is. That's going to be a vertical line. It's going to go through minus 1, the x. So it looks just like this. That's the graph of x equals minus 1. So what about this? X is greater than minus 1. Well, I've got to see which of these regions, this region here to the left of the red line, or this region here to the right of the red line, which of those actually satisfy this? Well, you just pick a point in the region and check. I just pick the origin. That's to the right. Does 0, that's 0, 0, so x equals 0. Is 0 greater than minus 1? It sure is. So in fact, this is the part of the world I want. But notice something. This is strict inequality. Remember, the previous question was y less than or equal to 3. This one is just x greater than minus 1. So in fact here, I don't actually want to include that line, because that's the line where x equals minus 1, and I'm not allowed to have that. I'm only allowed to have something bigger than minus 1. So in fact, I'm going to shade in a region. I'm going to shade in this region right here. But I want to actually remove that line. I can't talk about that line. I can only inch up to it. So in fact, this region, the region that's strictly to the right of x equals negative 1, but not including that line, would be the solution to this. What if I wanted to graph both of these things together simultaneously? So this and y is less than or equal to 3. Well, then I put those pieces together. So I put in that 3 line again. And then how did that go? Well, that went down here, if you remember. And now you see that, in fact, we have a lot of different colors here. And so where do both of these happen at the same time? That's where those colors actually overlap, where we have this sort of, I guess it's a brownish kind of a dirty color. It's not the pretty, whatever this is, that pinkish or sort of whatever kind of magenta, or I guess it's a cyan kind of color. No, it's a magenta kind of color. Thank you. And then this is more of a greenish color. Well, all the magenta are the points where the top is satisfied. All the green, those are all the points where the bottom is satisfied. Where are they both satisfied at the same time? In this region right here. And in fact, this is how you can graph a whole bunch of inequalities at once. You sort of see where the shading overlaps, and that's your solution set. These are all the points that satisfy both of these at the same time. Okay, up next we'll take a look at some examples of more exotic graphs and trying to see their intersections with inequalities. And then we'll take a look at applications in the realm called linear programming. It's not as bad as it sounds. Stick with me and I'll show you. See you soon.